Hey, what's going on? I'm here in Saskatoon on the train bridge, and I want to show you what the final project might look like. So what I'm going to do is I'm going to try to figure out how to turn my camera around first, and I don't know how to. Hey, what's going on? I am going to try to show you what a final project might look like. So I'm on the train bridge here in Saskatoon. I'm going to try to explain sunsets to you, okay? So there is a ton of different colors in there, and even in the clouds to the side, you see a whole bunch of different kind of pinks. You see yellow, orange, red. You see all those different colors during sunrise and sunset, but not during the middle of the day. And my question is, why is that? So I'm going to talk to you about two different things. The first one is the electromagnetic spectrum, and the second one is going to be scattering. So the sun is not changing colors. We know that, okay? But what's happening actually is because it's going through more atmosphere, because it's on the sides, that means more scattering occurs. What scattering means is when light hits different molecules, like water molecules or something like that, it scatters the light into all its wavelengths, okay? So some of the red light will go in some directions, some of the yellow in some directions, but mostly it'll get the short wavelengths, okay? So it'll be the blue and the violet. So during this day, we see a ton of blue and a ton of violet. During sunset, when we're going through more atmosphere, we don't get to see that stuff. That stuff's scattered because it's through more atmosphere. It's gone. It's out of the way. And we're seeing the yellows, the reds, and the oranges, okay? So that's why we're seeing all these different colors in the night sky at this time of the day. So I brought in a couple pictures to show you what scattering looks like. So in the first one here, you see the sun piling or coming into the atmosphere, and the violet and the blue is pushed away. In the second one as well, we see the same thing. We see the light, you see the blue being scattered everywhere into the atmosphere, and the other wavelengths entering it. Now, in the last one here that I'm going to show you, it's just representing how much longer the atmosphere, how much longer that path is that the light has to travel when it's coming to our eyes, okay? When it's at sunset and sunrise. When it's midday, it's so much less atmosphere that it actually has to pass through. Now, the electromagnetic spectrum, what that means is our eyes can only see a tiny, tiny, tiny part of what the sun's actually emitting, right? Because it has what does it emit? It emits X-rays, it emits, what else does it emit? So many different wavelengths of light that we can't see. We only see a tiny, tiny bit. So we need different telescopes and different tools to see all the other things that it actually emits. Okay, I had a little bit of trouble speaking there, so I apologize. But brought up the electromagnetic spectrum here, a picture of it. So starting on the left side there with gamma rays, and then goes to X-rays, and then UV, that's ultraviolet rays. This small tiny portion there in the middle, the colorful part, that is the visible light. That's what our eyes can detect. The next one is IR, infrared rays, and then radio waves. So the sun can emit to all of these ones and even more. But these are some of the main ones we'll talk about. Something to note is that each one of these has a different frequency and a different wavelength. That's what makes them different from one another. So just to quickly recap what I talked about, I said that the sun emits a whole bunch of light at so many different wavelengths, and we can only see a tiny, tiny portion of those, okay? The longest wavelengths that we see are the red ones, and those are the ones that are the least easily scattered. So the red ones do not scatter very easily at all. The easiest ones are the violet ones and the blue ones, and so they get scattered a ton at sunset and sunrise, so that's why we don't get to see them, okay? Thanks, class.